So far, you've done a lot of experiments with permanent magnets and some experiments with electromagnets. And now we're going to start looking at electric motors. And the cool thing about electric motors is all you really need to have in order to build an electric motor is a permanent magnet and an electromagnet. And if you have those two things, there's a way you can put together a motor. I'm going to show you two different recipes, and I'm going to ask you to give them a try. Give me a second, and I'll show you those. All right, this first recipe is what's called a homopolar motor. It's a very simple motor, but not a very common one. It's not the way most motors work. What we need some permanent magnets. I'm using some very small metal. They need to be metal and round jeweling magnets. And I've got a screw, and I'm just going to stick the screw to the magnets. And then that makes the screw magnetic. So we're going to stick the screw to the bottom of the battery and just let it hang there. And then I'm going to take a little piece of wire, and I just need to touch it to the magnet. Why don't you go ahead and give that a try, and then we'll show you the second recipe. Alright, now we're going to take a look at a more complicated motor. Probably the more traditional motor, the way that most of the motors in every electronic device that moves that you could conceive probably works. And in that motor, we have a coil that we are going to try to turn on and off. So that it's going to pull itself toward the magnet and then repel itself from the magnet, or just coast past the magnet. And so what we need to do is we need to build something that looks like this, okay? And I'll show you a closer image of that. But I basically took a piece of wire and I wrapped it around a marker to get it to be nice and round. And then I kind of tied off the ends and then stretched them out to the end. And that creates a structure that we call the armature, right? And what we're going to do is we need to run electricity through this coil, but we need it to kind of pulse through that coil. So I can do that one of two ways. When I strip the skin off that wire with some scissors, and I could either only shave some of it off so that half of it was showing copper and half of it showing still plastic wire, or I could just rely on it bouncing around a lot, because once it gets spinning, it can bounce around a lot, and that'll also create a pulsing motion. All right, so let's take a look at how this works. I got my magnet. I still need a permanent magnet, right? My battery. And I'm going to hold a couple of paper clips to that I've stretched out so that they're going to become the hook that holds this thing. And already you can see that, like, because there's electricity going through this is now an electromagnet, right? It's got a coil, and so it's going to behave kind of around that magnet. It's going to move in relationship to that. If I can get it to start to spin and pop around so that it's pulsing the electricity through as it breaks the circuit, maybe I change the polarity of the magnet to see if that helps me some. I can usually get to the point where it wants to spin. There we go, we got a spinning motor. It's just a matter of playing around with it to see what I can do to make it spin faster or slower. Alright. In the lab sheet, I'm going to post a whole bunch of different links of resources I can find to help you learn to make this better. Your challenge is to film yourself with your motor, or film your motor spinning and post it to my Flipgrid. We're going to see who can get the best motor built from home from scratch. All right? And we'll see what you can do. Good luck with that.